Hello everyone, my name is Renuka, Assistant Professor in Department of Electronics and Communication Engineering, Maharaja Institute of Technology, Mysore. In previous class, we have studied about the different methodologies, and one such methodology was, the Jordan's methodology. Let us now understand in detail about what do you mean by Warden-Mellor methodology and how is it different from Jordan methodology. So building an essential model, the environmental model. So that is one of the prime way, because in previous class we had dealt about what are the two basic ways in which you are going to classify Warden and Mellor methodology. What are the prerequisite, what are the requirements that are essential for any process to be defined, correct? So that becomes your essential. Those are the requirements, basic requirements which are essential for a process to be designed, right? So now in that we have what is called as environmental model, other is called as a behavioral model. In environmental model, we are going to study about how your device or your process or the plant will actually, or your system will respond to the environment, okay? How is it going to respond? Then the second is what is called as your behavioral method. In that behavioral model, what you understand is how your system is going to react, okay, based on variation in the environment. So the first is how the environmental factors will define the system. The other is how a system will react to the environment. So these are the two headers in which you have your Warden and Mellor complete methodology being designed, okay. So let us today study about what is meant by the environmental model, okay. So to understand this, we have a schematic diagram. So let us understand about the essential model of a Warden and Mellor methodology. In that, it could be easily understood with the help of this block diagram here. First is called as the essential model, as you see here. Other is called as implementation model. In essential model, it is again classified as the environmental model. The other is called as a behavioral model. So what you can see here is, in environmental model, you have what is called as a context diagram, okay. So what is a context diagram? It is basically to know how your entire process will be built on. What is the contextual idea that you have? What needs to be created, okay. So that is your context diagram, okay. And you have entity relationship diagram, okay. It is abbreviated as ERD, okay. So this is basically how you are going to explain or understand what is meant by your environmental model. Next you have the behavioral model. In behavioral model, you have three different headers. Those are your data flow diagram. What do you mean by data flow diagram? How is it represented? Then you have state transition diagram, STD, okay, how the states will change from one to another based on whether it is continuous or discrete. Then you have entity relationship diagram, that is ERD. So under these three headers, you are going to study about the behavioral model, okay. So this is about the essential model. So once essential model is designed, in the sense, what are the prerequisite a process should have? Once that has been designed, those are the essential requirement, then you have to think about the implementation model. In implementation model, what do we have? How does your system work with the basic method of what needs to be created or what needs to be implemented. So then the implementers will next go ahead and what will they do? They'll try to work on the different challenges that you encounter in the hardware as well as the software based on the hard constraints and the soft constraints, okay. So that becomes your implementation model. In implementation model, you have what is called as a process environmental model. You have process environmental model. Then you have the software environmental model. So in process environmental model, you're going to completely design what is a data flow. Then you have what is a store, that is how you're going to store the information, the state transition, okay, from one to another, whether it is continuous or is it discretized, okay. So that is your process environmental model. So PM is the abbreviation of the process environmental model. Then you have software environmental model called as SEM. And you have the three different headers again, as you can see, what is the data flow, what is the state transition, and ERD is nothing but the entities relation diagram. So all these three mainly will be put forward and they will be answered in the stage called as software environmental modeling. Fine. So once those two are completed, all the information has to be placed in the data dictionary. It is a basic essential library, I can say, where you have all the requirements of the entire process will be placed in data dictionary. So then finally you have the code recognition model, which is COM, and what is a program structure chart. So these are basically for the implementation modeling. So this is how your entire Ward-Mellor structure has been classified. One is what is called as a essentials, other is called as a implementation model. So now we are going to study in detail about what is the environmental model and what is a behavioral model. Okay. Environmental model mainly consists of a diagram, that is the context diagram, as we have already stated, and also it has an event list. These are the two entities. Okay. One, you have the complete context diagram. Context diagram is the pictorial representation of the entire process. Then you have the event list. What are the event list? Event list is nothing but what are the basic requirements that has to be met by the process during its environmental modeling. Then you have, there are simple rectangular box, you can just see here. If I take an example of a drying oven, the drying oven is mainly used to dry the components, right? So if you take that as an example here, what you see, this is the drying oven controller. This is the main controller that you're going to design, okay, which is described, or you can say the pictorial representation is a circle, a bubble we can call. Then you have rectangular blocks here all rounded. What is a rectangular box determined here? They are nothing but what is called as the terminators. Terminators are nothing but the exit end where it leads to the environment. Okay. So this is a system and this is the environmental factor, okay, of the process. And how are they connected? Either they are connected by a single straight line. If you just see here, it could be a continuous line or it could be a dotted line, okay, and you have two arrows here, okay, or it could be a single arrow, or it could be a two arrows with a dotted line or a single arrow with a dotted line. These are the four possible combinations. So let us understand how are they connected and what is a prerequisite of explaining what actually is meant by the context diagram here. Okay. So as I told you earlier, these rectangular blocks are called as a terminator block. Okay. So here what you see is the continuous line and you have a dotted line. So the continuous flow of any information, it mainly represents the data or the control signals for which it is always value available to the system. So if you just see here, you have a continuous line here and you have a single arrow or it could be a double arrow, right? So single arrow or the double arrow, no matter what they are basically it talks about the data and the control flow, okay, data or the control flow, which is connected from terminating block to that of your controller, okay, which is the main processor, which is represented in a form of bubble. Discrete flow issued for data or control, which is generated as a separate items or transactions. So once received or transmitted, the items is no longer available. So which means that it is not continuous, it is discrete and it is available only at that instant of time. Once it has been transmitted or received, you will not be able to get the same signal back. Okay, that becomes your discrete flow and hence it is represented as a dotted line. Okay, so all flows should be named and entered in the data dictionary. What do you mean by that? If you just see this diagram, all the flow from the external or the terminator end to the controller here is all connected and they are named. So it is important that you have to name all the lines which is being connected from the terminator end to the controller end. Okay, that is a prerequisite. Fine. And the first is you need to know what is the data flow, what is a control flow. So if you just see the solid, if you just see here, a solid line with double arrow is nothing but your continuous flow, which talks about what is the data that is being continuously being sent. Okay. Discrete, when you have a solid line with a single head. So if you have a solid line with a single head, so then it is continuous. So it is very easy to understand whether it is discrete or continuous just by looking at the lines. If you have a single arrow, okay, pointing from external or a terminating end to your controller, if you have a single arrow, then it is simply called as a discrete. Okay. Then if it is double arrow, then it is continuous. Only thing is you have to know what is the difference between continuous, that is a data, and the control line. If it is a control line, then it will be dotted, or you can say a broken line with 2 arrows. If it is a data, then it will be continuous line with 2 arrows. Okay. This is a major way to actually differentiate between the data and the control line. But it is very important for all the lines to be addressed, and it has to be named. Okay. So a dictionary. So we need to know what do you mean by data dictionary. A data dictionary contains entries describing in a rigorous manner and all the data elements of the system such that the user and the system analyst will have a common understanding of them. So it is very important to always define what do you mean by a simple data dictionary, wherein it is the major requirement, essential requirement for whatever you are going to define in your process. Okay. So the data elements in this sense include control flows as well as data flow, and it is also common practice to include in the dictionary description of the activity that the system performs. So data elements are nothing but the elements, for example, like that of you talk about the temperature, you talk about the guard. So what happens, they become the data element, right? So how you are going to define them? Okay, based on the nomenclature. So the name has to be given, the primary name. So that has to be placed in your dictionary. Okay. So the data elements in this sense include the control flows as well as the data flows. Fine. A data dictionary always forms a part of case tool. What is the case tool? It is nothing but computer aided software engineering tool, correct? So if you have a computer aided software engineering tool, then it is nothing but you have a data dictionary wherein all the information with an abbreviation will be stored in the main set, okay, or a library. Structure are of many forms but should include the following information. So if you just talk about the different kinds of structures, there are plenty of structures, but what is important or common is they should have the following information in them. Okay, what are the major information that you need to think about in any of the structure? First is a name. What is the primary name given? The primary name of the data or control item or of an external entity or of a process. You have to give a primary name like that of control, data, okay, enable, disable, okay, and you need to tell about whether it is a temperature control or a gauge. Okay. So these are nothing but your primary name and the data required. Next, alias. Alias is nothing but the other name instead of the primary name. If you analyzer, comparator, so they become they are not the primary name, correct? It is based on the action that is performed in any of the process. So those are called as alias. Okay, those are the names which is a name which is different from that of a primary name. Okay, like that of temperature, controller, okay, and a flow. Okay, these are all the primary names. Okay, so usage, where and how is it used, that is listed in the process activity that needs to be used, and whether the input or the output of the process are to be stored in the external entity. So what is the usage of such of these abbreviations that you are going to use? Are you using internally storage or externally, okay, or is just a data flow or the control flow? So you have to predefine it. So that will be the usage of each and every abbreviations. Okay, so these are the primary details that are required for any kind of structure that you are going for. Okay, so the content description, a description using a standard notation of the content. So content description is nothing but, for example, if I say a temperature, it is primary name, then what kind of temperature? Is it the temperature between 0 to 10 volts based on the variation, okay, in the heater? So then what is the, I have to define what is the preheater, okay, then the actual heating level, then the cooling level. So these are the three bases on which you're going to define the temperature, okay, your minimum, maximum, okay. Content description. A content description using a standard notation of a content. Then other information like what is the data types, preset values, range of values and other restrictions are some of the information that needs to be addressed, okay. So if a name already exists in a dictionary, any attempt to use the name for another flow will be detected and the user will be warned. So which means like, for example, if you have not given any aliasing name, if the same primary name is being repeated again by the user when he is trying to define another process, a sub-process, then when he tries to define that in the dictionary, a warning will be issued to him saying that this variable is already been, the content has already been declared, okay. So he or she has to set a new name for that content, okay. Prerequisites that are very important in order to define the entire context diagram, okay. So in the context diagram, we also have simple abbreviations. Let us know what they mean and what they are with a few examples, okay. So for example, if I have oven temperature, okay, then you have CD, okay. CD is nothing but the continuous data, okay. What is the CD here? It has been defined as the preheat temperature, drying temperature, cooling temperature. So all these things are being defined, correct. So you have a name here, okay. Then you have a short description saying that the CD, which means if I write a CD, it directly indicates what am I talking about, the preheating level, then it is a drying temperature, the cooling temperature, output from the temperature transducers, input to drying oven controller. So these are all your basic description, okay, for a simple oven temperature, which is a primary name, okay, and you're abbreviating it as CD, which is continuous data. Next example would be, so preheat temperature. So preheat temperature within this, okay, you're going to define that. What is a preheat temperature? It is CD again, it is a continuous data, and you again describe that as, because these are the variables, right. So these becomes your alias, correct, you're giving a different name. Now you have to define this preheat temperature. What is it? The range is between 0 to 100 degrees, okay. Measurement of temperature in preheat area of the oven. So this is the description of your, the sub names, okay. This has to be the content description, okay, and the temperature is between 0 to 100 degrees Celsius. It is defined. So the conveyor start, if I call another variable as a conveyor start, that is a primary name, and if I say DC, so I have to say what is the DC, it is the discrete control. So this discrete control ranges either it go to on or off based on the output from drying oven controller, input to the conveyor to motor controller. So here you have the description to say what do you mean by the conveyor start, okay. Next, guard lock, that is T. What is T? Again it is nothing but your terminating block. So terminating block, it is represented as a rectangular block, correct. So now you have external unit control operation of the guard locks. So you have the external operation of your guard lock. What are the three guard locks you have? In guard, out guard and the drop guard, okay. So all these three will be taken as a terminating block. That becomes your guard lock. That has to be again defined. So here if you just see, this is how you're going to set the variable names, and these are the abbreviations, okay, what kind of block is it? Is it terminating block, or is it a discrete control, or it is just a continuous data? So all these are being described here along with a complete description of the content, okay. This is how it has to be done. Next, a compound or a group flow is made up of three elements. So if I just call it as a compound or a group flow. So here if I take an example of a compound or a group flow, it is nothing but your guard lock, because there are three operations that has to be performed, correct. It is the in guard, out guard and you have a drop guard. So there are three operations that has to be performed by the guard lock. So which means if it is locked, then you have an indicator saying that now it will turn red and you have a component being sent on the conveyor belt. So when the guard is unlocked, what will happen? You have a green light saying that now the conveyor belt is not running. Now it is fine. You don't have any components being sent on the conveyor belt, right? So now what happens? There is a group of action that's need to be controlled, okay, and that has to be described. So okay, that is called as a compound or a group flow, and it is made of 3 elements representing the temperature measurement flows from each area to the oven. Then concise means to describe the information. For example, if I take a group flow, it is nothing but the guard status, that is the in guard, out guard and the drop guard. That is the best example. And event list, what do you mean by event list? It is nothing but a list consisting of the events that causes the change in the system, and that change in system results in the change in the output, correct? So now if you just see, these are the list, if I call these are the event. So the list of events that could change, okay, what are the list? Let us try to understand. A start, the start of a system, when is going to start, what time is it going to start, okay. So that also becomes a very important, so that also could change the entire system operation, isn't it? So start, in guard, out guard, then you have drop guard, pausing when you're going to pause it, okay, and conveyor fault, if there is any variation or problem in the conveyor belt, then what is conveyor fault? Then when you have to stop, okay, and you have oven temperature, what is the prerequisite for the oven temperature, so that it has to be maintained in the optimum level. Then conveyor speed, what should be the speed? For initially, for preheating level, what should be the speed? Until unless the speed kicks on to the one particular level, then you will not be sending any components on it, right? So we know about that, right? So these are nothing but, I can call it as the event list that could change a system, and that event in the system could change the output of the system. For example, if the conveyor belt, okay, is not running in the constant speed as required, okay, if there is a variable speed, then what will happen? Then you have to make sure that it has to attain to a optimum level, okay. Until unless it reaches, you will not be able to go ahead and send a component for drying purpose, right? Then you have to have an alarm system. Until unless you have an alarm system being activated, alarm system is very important. If the alarm system does not pick up on a wrong conveyor action, the speed of the action, then the whole system will fail, which will have an erroneous result, which is an output, right? So we have to have what are the list of event, or I can say a crucial list of event that could change the system operation, and that might lead a variation in the output, okay. So these are the event list. And what are the action that it actually takes? If I suppose if I take one of the example as pause, so stop conveyor, the action is to say stop for the conveyor, to stop the entire movement of the conveyor. Then a response, so there should be a conveyor alarm saying that now the conveyor belt has stopped working, so now there should be alarm that has to be set, and then it should be less than that of 0.5 seconds. So there should be a time description given to how long should the alarm be set. It can't be, it should not be like in an infinite loop, right? It has to come back to its original state. So the time has to be defined, fine. So this is one of the example. This is how you're going to set what are the different types of events, what are the actions that has to be taken, what is the kind of response and time set for each and every event has to be described in advance in the complete context diagram. Next, the event list shows the time response required for the response to the various event, including the cycle time. For the entire cycle time, what is the prerequisite that are very important in responding to each and every initial value. Though it is not for Ward and Mellor requirement, soft and hard constraint, tolerance should be indicated at this stage. So it is very important to indicate. Indicators are very important in case of it need not be just Ward and Mellor, but any kind of a system or methodology that we have to adapt, or we are planning to adapt, we need to have an alarm system indicator so that it becomes convenient for any operator to address those variations and make sure it has been debugged. Next is what is called as building the essential model, what is called as the behavioral model. So what is a behavioral model? How the system will behave to the external environment is what is called as a behavioral model. It shows how the system should respond to the event taking place in the environment. A hierarchical approach is used to build the model. A system is divided into various functions, okay, or I can simply call it as activities. So the entire task is broken into smaller activities. The functions are referred to as a transformation and represented in transformation diagrams. So there in when you're talking about the environmental model, you call it as a context diagram, but when you're talking about the behavioral model, you call it as a transformation diagram. So what is a transformation diagram? From one state to another state, how is getting transformed? Okay, if it is continuous, then it is discrete. Then if you want to have a continuous again, how is it going to get transformed? So these are all the basic functions that has to be referred to each and every activities. Example, drying oven has two transformation diagram. So if we still have the same example as a drying oven, then it has two transformation. Let us know what is this two transformation. So the bubbles with solid lines represent data flow or data transformation. So if you have a bubble is what? Bubble is nothing but wherein you have the process that you're going to define, right? So if you have the process that you're going to define as a bubble, okay, here one bubble, that is mainly nothing but the drying oven controller, right? So here when you're talking about the temperature, or it could be any other controller that you're looking for in a drying oven, then you have to have the bubble, that is the transformation. Okay, so the bubbles with solid lines, so those bubbles which are connected with the solid lines is nothing but the data transformation. Bubbles with dotted lines represent the control. So earlier in environmental model, you had both dotted line as well as a continuous line. Okay, there you had two arrows for a data if it is continuous, and a single arrow for if it is a discrete, right? But here what you have is, if you have a continuous line, okay, then you have what is called as a data transformation. If it is dotted or a broken line, then it is called, represent the control transformation. So you have just data transformation and the control transformation. So double line around part of bubble indicates multiple instances of transformation. So what do you mean by bubble, double bubbles? But you have multiple action that needs to be performed, okay, within one such system or one such activity. Let us look into what do you mean by this double line. So if you just see here, for example, in this diagram, you have control area temp, isn't it? You have a circle here, and if you see, there is another circle behind it, which means that there are multiple levels where you have to have a control area of the temperature. We need to have an analysis of multiple level of the control area of temperature. Okay, so it could be 1, 2 and 3. If it is a drying oven, it could be 3. Fine. So now the dotted line label enable and disable are called as a prompts to control area temp. If you see the control area temp here, you have two dotted lines. We have what is called as a enable and you have a disable. What are these? They are also called as prompting. Prompting in the sense whether you are enabling. So you are not thinking exactly about what is happening inside the system. Is it connected? You are just logically analyzing whether it is enabled or disabled. It is 0 or 1. Okay. So they are the prompt. If it is enabled, you do this action. If it is disabled, do this action. So they are called as a prompts. Okay. The enable and disable are called the prompts here, which are connected to the control area temp. Okay. So control area temp, it indicates whether the particular transformation is active or not. A transformation without prompts are assumed to be running all the time in the system is running, which means that if you don't have a prompt. So whenever it is enabled, disabled, it is the action based on either the operator or could be a system. But if you don't have any prompts, which means that the process is going on, it is running throughout. So we don't have any prompts. Okay. So the flows that enter and leave the diagram must appear on the context diagram. So if you take this as a context diagram, so line which comes in and goes out should all be named. Okay, that is what it means. There should be a direction of flow of the control. Okay, such transformation is given a number. So if you just see here, if you okay, they are all the control lines, but these are all the data lines. If you have a solid spherical circles here, okay, or the bubbles we call, so these bubbles are nothing but the data line. Here when you have a dotted line, then they are becomes the control bubbles. Okay, so now if you just see, there are many arrows, okay, and there are which indicates the direction of flow of control. Okay, and not just that, there are numbers given here, right? If you just see 1, 2, and you have 3, 4, 5 and 6. If you just see that, so you have 1, 2, 3, 4, 5, 6. So there are 6 bubbles here, which talks about how many data are there, bubbles are there, and how many controls are there, and it also talks about how many prompts are available, okay, and how many are running on their own without any prompts. Fine. And not just that, since it is labeled as 1 digit here, which means that it is a level 1 transformation. Okay. So transformation having a single digit number are said to be in level 1 transformation. So this is about how actually you are going to define a transformation. But set points, other is called as a guard locked. Okay. So guard locked, we know it is nothing but the group flow, correct, because it has more than one, that is multiple such control line which has to be thought about, right. So guard locks, and you have area set points, which plays a very important role in defining what is your control area temperature of an entire system, right. So now if I consider the expansion of control area temp, if you just see in the previous diagram, control area temp here, if I am going to zoom out and now I am going to understand what is the control that happens inside a control area temp block, because this is nothing but one of the primary listing. Now I have to understand what is happening, what is the function that is being described inside a control area temp. So if you just see here control area temp, so you have oven temperature, okay. In that you have what is called as read temperature transducer. Transducer, we know that it changes one form of energy to another form of energy, correct. Now if you have, then you have what is called as a trigger. Trigger, it is nothing but a prompt. Triggering is what? Again a prompt, isn't it? Because you trigger an input, right? You trigger an output, right? So what do you mean by that? Trigger becomes a prompt here, okay, indicating that the transformation is run once for every incoming trigger. So if the trigger is true, that is if it is high, what will happen? Then the read temperature transducer, there is a conversion for every triggered input only when the trigger is on. So that becomes your prompt, correct? So when a trigger is true, then you have read temperature transducer being converted from one form of energy to another. What is that? You see here there is a continuous line, correct? Then later you have a dotted line. So here in this transducer, what happens is, this indicates the transformation runs either in the periodic or as an event. The read temperature transducer is continuous data flow and the output is a discrete data flow. So if you see here, it is a continuous data flow because it is continuous line and it is a data, correct. And now the output of this will be a discrete, correct. But what happens is you should not have a discrete, because if you have a continuous temperature, which means that you are reading a temperature value and then it will be converted into zeros and ones. It discretized, right. Next you have to have the zeros and ones being again converted back to a normal temperature, isn't it? So again that conversion happens at what is called as a heat output. In this heat output, if you see the two lines which joins here, it is in turn converting what? It is converting your zeros and ones, that is a discrete value into a continuous value, and that is done by your heat output. Okay. So, this is how you are going to study each and every bubble, and you have to define each and every activity inside the bubble. Okay. Now, using the data flow, heat output provides a reverse operation of converting discrete data flow into the continuous data flow. So, if you just see here in this block, the entire block, what do you see? Here you have what is called as a read temperature transducer, converting from your continuous temperature into a discrete value, and after this discretized value, again there is a prompt here, correct, enable and disable, whether zeros or 1, okay, 1 zeros or 1s are available, then it is not going to resend again. Okay. So, then for that particular value you have a conversion of those discrete value into continuous, and it will be done by whom? It will be done by the heat output. Okay. So, there is a complete conversion inside the process which is designed, okay, based on the trigger. If the trigger is true, then the system will convert from the temperature being read from your continuous to a discrete, again internally enabling and disabling action, again zeros and ones, discrete value, again there will be plenty of prompts, and from there discrete to continuous will be done by the heat out. So, this is the major conversion that happens inside a system, which are the activities. The process is broken down into multiple activities, and these multiple activities has to be predefined, and all the description has to be addressed. Okay. This is about your second level transformation diagram. If it is a single transformation, then you have one digit, okay, like 1, 2, 3, 4, 5, 6 as a previous example. And if you go for the second level, it can be 2.1, 2.2, 2.3. So, you have multiple inner levels within a major level. Okay. So, this is all about study of Ward and Mellor about the behavioral model and the environmental model. We shall study about the different ways in which the path has to be identified in the next class. Thank you.